Hello students, then we are solving SC Verma chapter 32 electric current in conductors questions, and student, you can find out the link of solution of all questions of this chapter in description box. And if you are new on this channel, then please subscribe this channel and share this channel. So let us start our today's class. Student, we start today from question number 23. The question is, if the reading of ammeter A1 in figure is, you can see this figure for question number 23, reading of ammeter A1 reading is 2.4 ampere. It means, student, the current flowing through this section is 2.4 ampere. Student, the values of these two resistors here, in fact this is also given, 20 ohm and 30 ohm. 20 ohm and 30 ohm. These values are given in question. Okay, the current flowing through this section is 2.4 ampere. This is given. Then we have to find what will be the ammeters A2 and A3 read. Means we have to find the reading of ammeter A2 and A3. Means in other words, you can say we have to find the value current flowing through this section. Let this is I2, and also through this section let this is I3. Okay, student. Neglect the resistances of the ammeters. We have to neglect the resistances of these ammeters if there is any. Okay. Now, student, it's very easy question, and in fact, the important thing is that you can solve this question in many number of ways. Okay. Just see first. This is your first method. Okay. First method. Student, you can understand that the potential difference between these 2 points. Let if this is point P and this is point Q, then this point will be also P. You can write, and also you can write this point as Q. Okay. The potential difference between this resistor will be certainly equal to potential difference across this resistor, because these two resistors are across the same point P and Q. Means you can write potential difference between points P and Q. This you can write IR from Ohm's law. V equals to IR. The potential difference across this resistor is IR. Current flowing through this is 2.4 I, and the value of resistance is 20. And this will be also equal to this potential difference across this resistance. Okay, and the current flowing through this resistance is I2. V equals to IR, I2, and this is 30. And from here you can see this is 48, this is 30, I2, and from here the value of I2 is 48 by 30. This is 16 by 10. This is 1.6 ampere, and this is reading of value of I2. Value of IT means reading of ammeter A2. This is your answer. Okay. Now from KCL, you can understand, from KCL, Kirchhoff's current law or Kirchhoff's first law, you can understand that the net incoming current should be equal to net outgoing current. If value of I2 is 1.6 ampere, I2 is 1.6, this is 1.4, means I3 will be equal to simply addition of these two currents. This will be means 2.4 plus 1.6, this is 4 ampere is your answer. Means this is reading of ammeter A3, and it's your answer. Okay, student. Now, student, you can also solve this question from another way, M2. If you want to use Kirchhoff's voltage law, Kirchhoff's loop law, Kirchhoff's second law, then you can also solve this question by using that law. You can write here, using Kirchhoff's voltage law. Okay. You can see here that in this loop, potential difference across all resistors, sum of potential difference across all resistors should be equal to 0. Clear? Okay. Now, the potential difference across this resistance will be IR 2.4 into 20. Okay. Now we are moving inside this loop clockwise like this. Okay. So potential difference across this is 2.4 into 20. Now we are moving this, and current is moving this side, we are moving this side, so we will take minus sign, and now potential difference across this will be IR, current is I2 into resistance is 30 equals to 0. And from here you can also see that the value of I2 is 1.6 ampere, means this is reading of ammeter A2. And again, for finding the value of I3 means reading of ammeter A3, you can similarly here, similar to here, you can use KCL, and I3 will be 2.4 plus 1.6 equals to 4 ampere. Okay student, now you can also use the concept of the formula. In fact, you can say formula of current divider rule, using current divider rule. In fact, student, you must know what is the current divider rule. Just I am summarizing this here. Suppose that we have two resistances R1 and R2 connected in parallel, as you are seeing. And now if the net incoming current is I, obviously this current again will be I. Okay, now let the current flowing through R1 is I1. If the current flowing through R1 is I1, then, and the total current is I, as you are seeing, that then from current divider rule, student, we can write, just see carefully, we can write, if you want to write the value of I1, then I1 equals to total current. Firstly, you have to write total current into. If you are going to write the current through this resistance R1, then now here you have to write R2 and thereafter R1 plus R2. Okay student, now just see that how we will use this formula, current divider rule, okay, for solving this question. Now here you can see we have the value of this I1 2.4 ampere is given. So from current divider rule, student, we can write 2.4 equals to I3 into total current into 30 by 20 plus 30. Okay student, now this becomes from here you can solve that I3 equals to 2.4 into 50 by 30. This becomes 12 by 3. This becomes 4 ampere. Means from using this current divider rule, we are directly getting the value of I3, means reading of ammeter A3, 4 ampere. Okay student, now for I2, इसलिए I2 using Kirchhoff's current law, I2 will be what? I3 minus 2.4, this becomes 4 minus 2.4, this 1.6 ampere, the value of ammeter A2, the value of reading shown by ammeter A2. Clear? Okay, now we will now solve student question number 24. Question number 24. Question number 24. Student, you can see that the figure for 24 is given here. Now the question is, the resistance of the rheostat shown in figure is 30 ohm. There is a rheostat and the total resistance for that is 30 ohm is given. Neglecting the meter resistance, find the minimum and maximum currents through the ammeter as the rheostat is varied. Minimum and maximum current flowing through this ammeter. Let the current flowing through the circuit is I. Okay, now student, this is the original figure that is given in question. Okay, student, we can replace these two resistances which are connected in parallel by single resistance. These two are connected in parallel. We can write 10 ohm and 20 ohm. Their equivalent will be 10 into 20 divided by 10 plus 20. Okay, and this becomes 200 by 30, means 20 by 3 ohm. Means we can, in place of these two resistances, we can put here a single resistor of resistance 20 by 30 ohm. 20 by 30 ohm. Okay student, now we have to find the maximum and minimum value of this current. Student, you can see here the value of current I can be written as effective EMF 5.5, and there are two resistances 20 by 3 ohm and this variable resistance of rheostat. Okay, these two are connected in series to let in general the resistance of rheostat is represented by RH, since its value will change according to change in position of this jockey. Okay, when the jockey will be at this position, then no part of rheostat, part of any resistance will be counted, will come inside this circuit. Okay, and if the jockey will come in this position, then total 30 ohm will come in series with this resistance. Okay, so the value of resistance RH will be variable. Okay, and so we are writing it as RH. Now we have to find the value of maximum and minimum value of this current. Okay, now for I max means for maximum value of I, you can understand, you can realize. Okay, student, one more thing, we can write it some more simple, some more easy way like this. 20 by 3, this becomes 6.67 plus RH. Now for maximum value of I, since these two are fixed, this term should be minimum. This term should be minimum for maximum value of I, and this will be minimum when RH, value of RH will be minimum. When I max means RH minimum, the value of RH should be minimum. Only then the value of I will be maximum, and the minimum value of RH rheostat will be 0 ohm when jockey will be at this position. When jockey will be at this position, then no any resistance will come in series with this, means the value of RH will become 0, and in this case the value of current flowing through this circuit will have maximum value. Okay student, so I max means maximum value of current we are now writing. This becomes 5.5 divided by 6.67 plus the value of RH becomes 0. In that case the value of I will be maximum, and this becomes 5.5 divided by 6.67. this becomes equal to 5.5 divided by 6.67. this becomes 0.82 ampere is your answer. Okay, similarly student, you can understand, similarly for minimum value of I, the value of resistance of rheostat should be maximum, and its maximum value when jockey will be at this position, and the maximum value will become 30 ohm. Here you can write when jockey will be at let this is point N, this is point N, at point N. When this will be at point N, then the value of rheostat, the resistance of rheostat will be maximum, having value 30 ohm, because all these resistance, the value of all these resistance will come in series. Okay, and in this case the value of current flowing through this resistor, through this circuit, will have minimum value. Okay, so here the value of minimum value of current we are calculating. This becomes 5.5 divided by 6.67 plus value of RH in this case will be 30, and this is 5.5 divided by 36.67, and it will be 5.5 divided by 36.67 equals to 0.15 ampere. Okay student, this is your final second answer. Okay student, now we are going to solve question number 25. Question number 25. Student, this question is saying 3 bulbs each having a resistance of 180 ohm are connected in parallel to an ideal battery of EMF 60 volt. Okay, we have 3 bulbs and each having a resistance of 180 ohm, and they are connected in parallel. Okay, the situation is like this, and In turn, this combination is connected across a battery having EMF 60 volt. Okay student, now find the current delivered by the battery when A, all the bulbs are switched on, 2 of the bulbs are switched on, and C, only 1 bulb is switched on. Okay, there are 3 parts of question. In part A, we have to find the value of current delivered by this battery, okay, when all the 3 bulbs are switched on. Okay student, in this case the equivalent resistance, since these 3 resistors each having same value 180 ohm are connected in parallel, so equivalent resistance will become equivalent resistance REQ. You can write this becomes 180 by 3, this is 60 ohm. So current flowing I, the value of current flowing through the circuit will be effective EMF 60 divided by effective resistance 60. Clear? According to Ohm's law, V equals to IR. This becomes 1 ampere is your answer. Okay student, now you can also in fact use Kirchhoff's voltage law for solving this question. Just you will have to for this you will have to distribute this current, and the current will be distributed equally among all these 3 sections because the value of each resistances are same. So in that case the current flowing through this will be I by 3, and thereafter you can write the loop law, Kirchhoff's voltage law you can apply, and from that you can write the expression like this. Potential difference across this resistance will be I by 3 into 180, I by 3 into 180 minus 60 equals to 0, and from here you can also again you will get the same value I equals to 1 ampere. Okay student, now we are going to see the next part. B, 2 of the bulbs are switched on. Now when the value, we have to find the value of current I when only 2 of the bulbs are switched on. Suppose the switch here is now kept open, so no current will flow through this resistance, and in this case only these 2 bulbs having resistances 180 ohm will be switched on. Okay, and so in this case you can understand the effective resistance will be, in this case effective resistance will be 180 by 2, because there are now only 2 resistances. This will become ineffective because the circuit is open circuit, and 90 ohm. So in this case the current flowing through will be, since EMF having same value is still 60 by equivalent resistance 90, this becomes 2 by 3, this becomes 0.67 ampere. Okay student, again you can again use here KVL, and in this case the current divided will be I by 2 because this is not ineffective, and so thereafter use equation for that. Now in C part the question is saying only 1 bulb is switched on. Now imagine the switch here is again, this becomes also kept open. Now in this case what will happen, these 2 resistances will become ineffective because they are now open circuit, no current will flow these 2 resistances, only 1 current will be effective in this case. So here in this case effective resistance will become 180 ohm. So in this case the current flowing through there, and the EMF is still 60, I equals to V by R according to Ohm's law. 60 by 180, this becomes 1 by 3, this becomes 0.33 ampere is your final answer. Okay student? Okay student, so now we meet in next lectures with the solution of next questions. Thank you.